Welcome back. Today's topic is somatic embryogenesis. So, somatic means we know that the somatic cell or the vegetative cells, right? So, one is somatic cell and one is germinal cell. So, somatic means vegetative cells. Okay. And what is the meaning of embryogenesis? Embryogenesis is the formation of embryo. Okay. So, somatic embryogenesis is the formation of the embryo from the vegetative parts. Right? So, embryos generally originate from the zygote, right? First, there will be sperm and there is the egg. Then, after fertilization, it will produce the zygote. Then, further, it will produce the embryo, right? But we are taking the case of somatic cells. Okay, so in this case, embryos do not necessarily originate from zygote. Instead, they originate from a somatic cell, and that the formation of the embryo from the somatic cell is called the somatic embryogenesis. So, somatic embryogenesis is the process in which a single or the group of cells initiate the developmental pathway that leads to the formation of the, here in this case we can say, non-zygotic embryos. Correct? I just said the zygotic embryos develop from fertilized egg and that produce the zygote, whereas the non-zygotic embryo develop from cells other than zygote. Right? And these somatic embryos are bipolar in nature. What does it mean? It consists of both the plumule and the radicle. The plumule is the part which develops into the shoot and the radicle is the part which develops into the root. Correct? So next is about the formation of the somatic embryos. It takes place by two different methods. First one is the direct method and second one is the indirect method. Okay. So let's discuss first the direct method. As the name itself indicates that direct method means from a cell or from group of cells there is the formation of somatic embryo, right? So first the cell or the group of cell is placed in a solid or the liquid medium which is supplemented with 2,4-D. Okay, that is the growth regulator. And in this case there is no callus formation takes place. So the directly from a cell or group of cells without the production of intervening callus, the embryo will form. Okay, but it's very rare in condition. Okay. Then the next thing is about the indirect somatic embryogenesis. In case of indirect, as I said, the same thing, the cell or the group of cell first, it's supplemented with the 2,4-D medium. Okay. And in this case, the callus formation takes place, and after the callus formation, from the callus tissue, the embryo will form, and in that case, the medium is either lake of 240 or there is less 240, and it is very common in nature. So next we'll discuss about the somatic embryogenesis process. So as I said, the first is the somatic cell, right? So first this is the somatic cell. Yeah, this is the somatic cell. Then it undergoes the cell division and it produces first the one cell proper, then the two cell embryo, that is the two cell embryo, then the four cell embryo by further division. This is the apical part and this is the suspensor. Okay. Then the four cell embryo, then the octine stage, then comes the dormitogen stage. This part was a question on CSANET part B question, that the hypophyseal region it found in each stage of somatic embryogenesis. So the answer it is in the globular. After the dormitogen stage, there is the electrocular stage, and here the hypophyseal region. Then the mid-globular region, then the transition stage, then the hard stage, and this is the torpedo stage. Linear cotyledon stage. Okay. So you can see this one, the first is the globular, this is the globular stage, then the hard stage, then the torpedo stage. First, the somatic embryos develop from a single cell or from a group of cells, and by the repeated cell divisions that lead to the production of group of cells that develop into an organic structure, that is the globular stage, and further development it results into the heart shape and the torpedo stage, from which the plant embryo develop and the plants can be regenerated. Okay. Basal region, central region, and the apical region. Thus the two cotyledons. So steep is first a single cell, right? Then group of cells, right? Then the formation of after two cell stage and the four cell stage. And after formation, the formation of globular stage, right? After globular stage, there is the formation of hard stage, and after hard stage, there is the formation of torpedo stage. Right? Then the mature embryo. Right? So next is what are the applications of the somatic embryogenesis. So some applications are it helps in the production of the artificial seeds. It is suitable in the suspension culture, and it has a high propagation rate. Okay. So these are the applications. So this is all about the somatic embryogenesis. The first somatic embryogenesis it was tested in the carrot by the suspension culture. So let me summarize this once again. First about the somatic embryogenesis. Somatic embryogenesis means the formation of the embryo from the somatic cells. Then it is two types. One is from the direct and one from indirect method. One and direct method, that is intervening form, that is the callus formation, but in indirect form, that is the callus formation takes place. And the stages, then from a single cell there is a group of cells formed, two cells, then the fourth cell, then the octant stage, then the globular embryo, and the hard stage embryo, and just the topless stage, and give rise to the somatic embryo. So this is the sequential stages of the somatic embryo development. If you like this video, hit the like button, share with your friends, and do not forget to subscribe to this channel. Thank you.